Hey everyone, my name is Dan Sykes and welcome back to the Analytical Chemistry Educational Resources YouTube channel. We're in the video series, Why on Earth Would I or Anyone Ever Choose to be a Chemistry Major? And in episode 1, we left off with these 3 questions. What does the chemistry major look like? There are a lot of similarities to the chemistry major among the various institutions that offer chemistry degrees, but there are also some key differences that we need to look out for. Whatever program you choose, what are the opportunities and experiences one should expect as part of their curriculum within the chemistry major? And then once you've obtained that degree, what can you do with that chemistry degree? And so these questions are interrelated. And so it's very difficult to answer one without touching upon the other ones. And so first, what we're going to do is take a little bit of a step back before we get to these and think about, well, what am I trying to obtain with this chemistry degree? It's not just a piece of paper, but you're trying to gain some skills and competencies that will allow you to compete for essentially the good jobs. Because in chemistry, in industry, there are good chemistry jobs that are fun and exciting and challenging, and there are some that are, rather mundane and boring. And you want to be competitive for those top chemistry positions, whether you're going to industry right out of your bachelor's or after obtaining a PhD. And if you go to graduate school, you want to be competitive to get into the graduate schools that you want to, and also be competitive once you're in that school to work with a faculty member or members that you want to work with. And so the skills and competencies that you obtain are really important because they are what make you competitive for whatever your next step is after obtaining your degree. Okay, so that's what we want to look at first. What are the skills and competencies industry is looking for? And really, it's the same thing as for grad school. Whatever's going to properly prepare you for industry will also prepare you for graduate studies as well. Okay, so let's see here. We're going to go to this next slide. And so the question is, do I have the skills and competencies to be competitive? Will I obtain these in the chemistry program or any science program that I elect to follow? Okay, so now we are interested in this with respect to my program here. And so we follow essentially some of the trends that are taking place, and we ask companies what they're looking for, et cetera. Now, the American Chemical Society, which is the largest professional society in the world, is the main accrediting body for chemistry programs within the country, within the United States. And they haven't kept track recently in terms of some of these statistics I'm going to give you. So the last available data was in 2009. It may seem a little bit old, but it's really not. Probably the number of chemistry degrees hasn't changed significantly since then. But anyway, in 2009, just over 14,000 students graduated with a BS degree in chemistry. That's what was reported by all the chemistry undergraduate programs in the country to the American Chemical Society. And of that, about 40% of the students continued on into graduate studies, whether at the MS or PhD level. Okay, that's great. But the question is that there are 60% of those students then are going into industry, and maybe even some fraction, and maybe not completely 60%, but some fraction going into professional schools like med school, pharmacy, law, things like that. But essentially, it's about a 40 to 60 breakdown. And that's probably true of each individual program at a given university within the country. Some may have a little bit more students going into graduate school programs. Some may have slightly more going into industry, but it all averages out to about a 40-60 ratio, maybe a 50-50 ratio nationwide in terms of students interested in going to industry versus graduate school. So that means the academic programs have to really cater to those two markets. We need to instill the skills and competencies in our students that will make them competitive in both of those markets. Fortunately, as I mentioned earlier, those markets really desire the same skills and competencies for the most part. But there are some needs within industry that academics just cannot provide. And we'll get to that. Okay, so the goal here is that now our program, we interact with numerous companies every year. And over the years, I've been here for a long time, we've surveyed over 100 companies and industry partners, asking them, what do you want to see in our students when they go to apply to any positions you may have open? Okay, so I'm going to list essentially those in numerical order that are mentioned the most. And I'm going to start with number 2 because we're going to come back to number 1. But this is the second most often skill and or competency that these companies that we've surveyed expect to see or want to see in their students. And it's not a company just says, oh, I just want someone to communicate effectively, both oral and written formats, and that's it. They've listed several skills and competencies that they're looking for. And so these are ranked in terms of the amount of times or the number of times that they were mentioned by our industry partners. So first is the ability to effectively communicate both oral and written. Very important because science is not performed in a vacuum. It's not an individual working in a laboratory anymore, shuttered away from the rest of the world. That's just not how science is performed anymore. And in fact, those problems that are the most interesting to go after them are the most complicated and require multiple areas of expertise, and no one person can essentially have or be an expert in all those different areas necessary to tackle the real world problems of today. So we need to be able to communicate with each other in both oral and written formats. And so they want to see that, and they want to see essentially programs that give their students the ability to communicate in both formats. Okay, so the next one. Oops, sorry, I skipped ahead, is knowledge retention. They want you to kind of know something coming out of your program. So specific knowledge skills and some broad knowledge skills. So they want you to be good fundamental chemists or good fundamental scientists. And if they ask you a question related to some basic fundamental principles or concepts, they expect you to be able to answer and answer using the language of chemistry, so that you essentially are making full use of the 4 years within that chemistry program. So you are using language specific to chemistry or science, but in a way that you can express your knowledge of these materials to a general audience. So there's a push and pull there a little bit. You need to learn the language of chemistry, but you need to be able to convey that as well to a general public. Okay, so there's also some specific knowledge and skills. So you've had hopefully some experiences here that allow you to dive in a little bit deeper to some specialized areas of chemistry. So what they don't want to do is ask you a question about something, say, well, I don't remember, but I know where to look it up. That's the worst answer you can possibly, you should know how to access information from the literature, etc. But what you don't want to do is essentially say, well, I don't remember, especially for fundamental stuff, but I know where to look it up. Now, it's okay to say, I don't know. Okay, but if you're saying that to every single question when it comes to some basic concepts, etc., there's an issue there. And that means that you didn't retain any information, right? So I want to be able to speak with you on the fly about things that are of interest or importance to you and I and the projects that we're working on, without you having to constantly look up what a word is in a dictionary or in a textbook or something like that. Okay, so the next one is essentially the ability to work effectively with others and teams. Yes, obviously, no one wants to work with anybody who can't work with other people. Now, I think the ability to communicate, the ability to work effectively with others, being a team player, these are all very important. There are times where we need to work independently and show that we can work independently, but we always must be able to work with others. So these are very important skills and competencies. Safety. You need to know what safety looks like at work, especially when you're working with chemicals, etc. Not only to be protective of your health and welfare, but to be protective of the health and welfare of others around you as well. So that you understand the importance of safety and safety culture at work. Ethical judgment and decision making. Well, we want honest people, right? Anybody wants an honest person. We don't want to work with somebody who's very difficult to get along with and essentially will do what they feel is best, absent essentially any ethics associated with those decisions that they're making. So we want people to be ethical. We trust that people are being ethical in their performance of their activities and in the manipulation or the handling of the data, et cetera, that they're generating. So this is extremely important. Okay. And then number one is the ability to apply knowledge and skills to real world settings. And this is really related to number three as well. So, the surveys they send out to companies, it's a broad range of companies that always say, well, we want team players, we want people who are ethical and safety. Yeah, every company wants that. But when you start asking STEM related industry, right, we want you to know something. They do, and graduate schools want you to know something coming in as well. So something to really ensure that you've essentially gained something from your undergraduate education. So the ability to apply your knowledge and skills to real world settings. In other words, it's not just regurgitation, right? And I think that's what a lot of students are used to coming out of high school is just recall. Right, on a test, all we're going to give you are questions that essentially require simple recall. That is not the case. In all of my courses, I require my students that if all you can do is simple recall, well, that's a non-passing grade. That's a D or an F. I'll give you a few plug and chug type questions, etc. That may get you into the C realm. But if you want an A or B in that class, you must demonstrate some ability to take what you've learned and apply it in an insightful way to a new problem, not a way out there problem, but a problem that definitely requires you to use material we just covered. Okay, it tells me that you truly understand the material that we just covered. And that's what essentially any industry wants. They want you to be able to critically think through some problems. Now, it may take a while to critically think through a problem and arrive at a successful conclusion, or you might arrive at a conclusion that says, well, we can't go down this path. But they need you to be able to think on your feet and use what you know in innovative and insightful ways. That's what companies are looking for, right? And so your curriculum needs essentially these 6 skills and competencies. You really need to address these at all levels of the curriculum. So you have practice using these skills and obtaining these competencies multiple times through multiple levels in multiple courses and multiple experiences so that you can demonstrate this on the job or even at the interview. Now, we've also asked companies a couple of other things, and these are not questions you will see on any broad-based general survey. But what I wanted to point out is that if asked, companies also desire one other thing, and even graduate schools in terms of, can you use, hold on just a second here, can you use instrumentation? Okay. And even troubleshooting and modify and repair. You'll find that in most graduate research groups, they're using instrumentation. Oftentimes they're modifying instrumentation. But what they need to know is that you can essentially have some understanding of how measurement is being made. Any instrument when turned on is going to give you a number. It doesn't mean that that number has any relevance to the physical and chemical properties of the system that you're observing. None whatsoever. Not until you've essentially ensured that your data collection, data processing parameters, and the manipulation of that data once you've had it is essentially maintains the integrity of that data. Okay, and you've calibrated it as well so that you know that these responses are in fact reasonable estimates of some aspect of your chemical system, whether it's chemical or physical. So do you know how to use instrumentation? Do you know how to maintain this? Do you know when an instrument's not working correctly that's giving you numbers that you shouldn't be trusting? Okay, and this is an important thing here is that industry doesn't get this. 99% of all students coming out of undergraduate programs have essentially very limited exposure to chemical instrumentation. What you typically get is essentially you create something in the lab, you make something, whatever, you take it and you put it in the instrument, you press a button and you get a result. Okay, that is not using the instrument. Okay, that is essentially, that's great, you press a button, get a result. And a lot of programs don't even let you do that. So oftentimes you have to give them a sample to your TA, your teaching assistant, and they give you a result back. One, because they don't have enough of the instruments for every undergraduate student to be able to collect their own data, et cetera, or they're worried that somehow, because of multiple users, there's a chance that the instrument might go down, and they don't have the resources, whether it's the expertise or the funds to make those repairs. And so they limit access to that. So they may have some equipment, but they limit access to it. And that's okay. That's the conditions under which they operate. Okay. And so if you open up your instrumentation to student use, you do invite those issues in there that instruments are going to go down. And so you have to have the in-house expertise to be able to repair those instruments on a relatively routine and rapid basis. Okay, so this is why instrumentation skills are highly valued, but rarely achieved in undergraduate students, just because you don't get that much opportunity above and beyond the simple, you put a sample into the instrument, press a button and get a result. So every program is very good at teaching their students how to read the result, how to interpret an NMR spectrum, how to interpret an FTIR spectrum. But very few students really know how to operate an NMR and FTIR, right, with respect to method development and validation. That includes liquid chromatography, et cetera. So very few students ever come out with that type of experience unless they obtain it through their research experience with a research group, right? Independent of their coursework, but as part of their undergraduate research experience. And so this is a highly valued and desired skill in industry, and even for students going into graduate school, being able to essentially say, yes, I have experience with instrumentation, et cetera, beyond just the simple sample insertion and press a button. That is, or can be an important talking point with respect to joining a graduate research group as a graduate student. Okay, and again, actually, if you know one or two instruments quite well, that really is a good portal into using other instruments as well, because for the most part, lots of these instruments essentially have fundamental design. The theory and fundamental designs are very similar to them. So if you have extensive experience with FTIR, well, you know what? That's going to translate very well to Raman. That will translate very well to UV Vis. And so there's some key technologies in instrumentation that if you are very good at, with lots of experience with, that skill set associated with that instrument will translate very well to other instruments. And so it's very good. Okay, so these are the skills and competencies that you're looking for. And if you can get that seventh one there, the ability to modify, troubleshoot, maintain instrumentation, you will be quite competitive for any job in industry and even at the graduate level as well. Okay, great. So this is what we want to do. Okay. And really, where are you going to get that experience? Well, it's the laboratory program associated with the undergraduate chemistry department. That is the make or break for these skills and competencies, right? So we're all very similar with respect to the types of courses that we offer, okay? Where we differ, okay, will be in the laboratory experience we offer our students, okay? And that's really where you should be basing your decision on where to go, right? You do want to go to a school that fits your personality, et cetera. And if that's a small school or a large school, a large department, a smaller department, whatever it is, you want to make sure that at whatever institution you choose, that you're choosing one and a program that provides you with a quality laboratory experience, because that is where you're going to get most of these skills and competencies that make you highly desirable, highly wanted. Okay. Now, I'm going to go off on a little bit of a tangent right here, because there's one thing that industry also is looking for that they rarely get as well from an academic program, students coming directly out of an academic program, and that is data management skills. I mean, and that includes statistics, right? And big data generation and manipulation and data mining and stuff like that. And it's very important because in industry, right? Most industries, whether it's making a product or whatever it is, they're generating some number associated with that product that tells their clients that this is the product that they want. They want to be purchasing this. They want to be using this. Numbers associated with the safety of that product that you're getting, the efficacy of that product. Everything is essentially supported by data, huge amounts of data, which means there must be some type of data management and quality control and quality assurance mechanism behind whatever's being produced to support what is being produced, to support the fact that the numbers and the claims that you're making are justifiable, that they are essentially, there's quality behind those numbers, and that you can trust those numbers. Okay. And so the QA QC environment of industry is unlike anything we can provide in academia. We don't operate under the same standards. We don't have the same type of scale. We don't have the need as much because we don't have as many individuals contributing to that bank of knowledge that goes into that QA QC architecture behind every industrial activity, et cetera. But it's something that if you have some idea of what's going on with that, with the QA QC platforms that companies rely upon, that's a good thing, right? And that's how you get to move up. Lots of times you get into a company, and after a while, you don't want to be a bench chemist. You want to go into management. So you want to manage a lab, you want to direct a lab, you want to be unit director. That requires extensive knowledge of the QA QC architecture of that system. Okay, so starting now and thinking about it, knowing and letting potential employers know that this is important to you, and you know that it is, and so you have some understanding of it, may not experience in it, but understanding of it goes a long way. And when it comes to graduate school, if you're producing things, IP, right, your own proprietary information, where you want to produce patents, etc. You want to publish a paper and someone challenges you on your publication and your results and your interpretations. Your notebook, laboratory notebook, must be able to back you up. The laboratory notebook is absolutely critically important to the chemical enterprise. Okay. And even in industry where they have electronic notebooks in a lot of cases, right? These electronic notebooks are a lot different than what you see in Gen Chem. So many Gen Chem laboratory courses have electronic laboratory notebooks, and they are electronic, but they're essentially more to streamline and grading than it is for anything else, right? They want to simplify the grading process, streamline it, and make it more comparable in terms of the grades that are handed out across multiple sections. And so these entry-level electronic laboratory notebooks are mainly for to facilitate grading. That's all they're for, because they're so scripted that there's no thought put into it. Right. And so the students have put no thought into constructing or adding information into that. They just do what they're told. And so they don't, you come out of that experience not really fully understanding the importance of proper documentation and the importance of that laboratory notebook. And so, in your curriculum, the standards for laboratory notebooks should be elevated every step of the way in that curriculum, so that when you come out, you should have a solid notebook. And I tell my students in my analytical courses, take your laboratory notebooks and analytical courses you take from me at the sophomore and senior level, take them to your job interviews. They will be wholly impressed with your laboratory notebooks because it will demonstrate to them, right? And you have concrete proof that you know the importance of the laboratory notebook. Now, is it the only deciding factor in hire you over somebody else? No, but if they have two comparable candidates and you have that laboratory notebook, you are getting the job. Okay, so on the right, on the screen right here, it says using chemist and chemistry as keywords. And we surveyed Aerotech, which is a recruiting agency, and also the American Chemical Society as well. I don't know if I have that information on this slide or the next one, but we've done it both. Now, Aerotech mainly posts positions for BS level and MS level positions. And you can see that QA/QC is preferred or required qualification for these positions. And, so it says it's important. QA/QC, data management practices, is extremely important in industry. And so if your program in any way can address the importance of that, okay, that's a leg up. Okay, and so we put this screen up here because we're working on developing a statistics data management set of courses within a given curriculum, helping to establish this. And so the diagram up there is really complicated, showing how essentially it's an industrial model of how the QA/QC system and data management system are folded into everything that they do. and then how essentially the course sequence that we were developing would essentially map to the skills and competencies with respect to statistics and data management industry would really love to have, would really love undergraduates to have. It's a nightmare, right? And this is the reason why undergraduate programs really can't provide that. Now, there are some programs that have a course in chemometrics, or they may require that you take a course in statistics, etc. But there's really no coordinated attempt in any curriculum that I'm aware of, chemistry curriculum that I'm aware of, that really models where the students are taking something they learn in one course and transferring it and building upon it in a subsequent course and subsequent. No coordinated activity that really provides students with an overall view of what QA, QC, and data mining and data management is and how important it is to industry. It's very tough. We don't even do that. It's just very difficult. We do what we can in my analytical courses, and so they are connected with respect to each other, but it's not connected across other courses within our curriculum. And so oftentimes, if you look, professional master's degrees, which are 2 year degrees that are typically non-thesis related, that students go to, they usually go to these professional masters because they want to go into industry. They don't want to do a 5-year PhD program after their undergraduate, but they're willing to do 2 years. A lot of these programs do embed QA, QC, data management statistics within that 2-year curriculum to give students a boost, a leg up for those jobs in industry at the master's level, where they can demonstrate, yeah, and they have added skills and competencies and knowledge with respect to those systems. Okay, great. So this is something that most programs at the undergraduate level, we don't do a very good job with. Okay, so now the big thing here is that, right, our programs are very good with respect to providing a theoretical framework for chemical concepts and principles, et cetera. But the practical application of those, which is really the laboratory program, right? There's a big gap and can be a big gap, especially if we want to look at it in terms of the theoretical knowledge as being academics and the practical application being industry and grad school as well, taking what we've learned and be able to get up to speed pretty quickly to do independent research at the graduate level. There's a gap, right? And it's a major gap and can be a major gap. And so what bridges that gap for any program is the laboratory course curriculum that they offer and how good that laboratory course curriculum is at narrowing the jump, that divide, okay? That jump across that divide. So, and the reason why then, especially with that QA, QC and lack of real instrumental experience, okay, is that when science, when individuals graduate with this degree in science, right, they're going to assume positions in analytical laboratories. When I say analytical, that means clinical labs, crime, forensic labs, drug labs, environmental labs, pharmaceutical, toxicology. These are all analytical chemistry-based labs, okay? You go undergo nearly a year of on-site training before you are certified to independently operate an instrument and collect or evaluate study case data. Why? Because you have to learn the instrumentation. You have to learn the QA/QC structure surrounding every particular activity you're doing and measurement you're making, and you have to hit those numbers. They're going to be testing you. They know essentially how much of chemical A is in this matrix right here. So you must come up with that exact same number within some very narrow tolerance, right? Plus or minus uncertainty. Otherwise, they can't trust you to obtain correct information. And so it can take between 9 and 12 months for a student entering a position in industry to actually have security, job security in that position, because that's how long it's going to take for them to reach those benchmarks that industry has set for them. Okay, and before that time, or if you never reach that ability, you're going to be let go. So anything your undergraduate program can do to shorten that time frame, instead of 9 to 12 months, anywhere from 3 to 9 months, essentially, that industry, that particular company is going to go to your program and hire your students because they know that the amount of time, energy, and money they must invest in you to get you up to an independent working level is much less than it is somebody from another institution. So this is very important. And this is essentially the laboratory curriculum within the chemistry program that you've selected. That is the make or break for you in terms of getting the desired skills and competencies that will make you the most competitive, not just for industry, but for graduate school as well. Okay. All right. So remember now, what you're looking at then are the resources and expertise, right? You are essentially purchasing access to resources and expertise. You're not purchasing a degree. It's not a loaf of bread at a grocery store. You're purchasing access. So what you or how you, the effective use you make of those will determine whether you have attained the skills and competencies that make you competitive. Okay, so one, resources and expertise. Two, the laboratory program is absolutely critical, and that ties into the resources. What resources do they have? Do you have hands-on use of the instrumentation available in the instructional program? Okay, or is that only available to you if you engage in undergraduate research with some research group, right? And so what you want is to be able to have access to resources within the laboratory program, hands-on use of instrumentation, method development, method validation with particular different types of instruments, and also have the ability to pursue research opportunities, maybe several research opportunities. Maybe work for this faculty member for a little while to understand maybe what synthetic organic chemists do in an academic environment. And then maybe come over here and work with an analytical chemist and modify an instrument in the lab that will allow you to perform a measurement that you couldn't do before. And that allows you to characterize a chemical system in a way you couldn't before prior to that modification. Right? Find out how an analytical chemist works. So make sure these opportunities exist because those are what are going to make you competitive. All right, so we're at the end of our time here. So now, remember, this is all skills and competencies based, right? That's how you're selecting your program, whether it's chemistry or any other science or probably any other discipline, science and non-science, is what's the expertise and resources that will be made available to you? What does the laboratory program look like? What are the other opportunities look like? That all feed into those skills and competencies that you can demonstrate that will make you competitive. Okay, all right, great. So once you have those skills and competencies, what can you do with a chemistry degree? Okay, and so that's what we'll look at next time. And we'll look first at industry. What does a chemistry degree look like? What can you do? What are the opportunities in industry? And of course, the answer is almost anything you want to. But we'll look at it from an analytical chemistry perspective, and we'll focus mainly on chemical industries. But we'll also go outside that a little bit. And in subsequent videos, I'll bring back some former students who are working in industry, and some students have gone on to graduate school, and we'll talk about what their experience was at the undergraduate level and how that prepared them for the next stage of their career, whether it was industry or grad school. Okay, so it's not just me talking and providing tips and pointers, etc. Okay, all right, take care.